Hi, I'm Tony Northrup, and this is my study guide for the FAA Part 107 UAS drone certification that will allow you to fly drones commercially within the US. In other words, if you want to take real estate pictures or take mixed drone photography into your wedding photography, this test is something that you need to do that legally. Read the description down below. I have included a table of contents because this is a very long video. It'll let you jump to the parts that you're most interested in. You probably will not absorb all this information the first pass, so you might want to revisit some of it. Table of contents also links to my free study guide that will give you more information in written form and links to things like practice tests that can also help you get through it. Why would you want this? As I mentioned, you need it if you want to legally, commercially fly a drone for, say, photography purposes in the United States. And that kind of includes YouTube, because you can make money from YouTube, so it's kind of considered commercial. The FAA hasn't been prosecuting YouTubers like, say, Casey Neistat. But at the same time, for us, it's a good idea to do it even if we use drones in our YouTube videos. How do you do it? Check the description down below. My study guide will have like specific phone numbers you can call, but basically you'll make a phone call. You'll call up the agency, the testing agency, and you'll give them your full name and your date of birth and like your county of birth and like weird information like that. And then they will call a testing center in your area, schedule a time for you, and you'll go and take the test. Sometimes you can even schedule it for the same day, so you don't necessarily need to plan way out. I just planned one day out and that was fine. When you show up to the test, you bring your ID and basically nothing else. You can't bring a phone or anything. You can bring in a 4-function calculator, meaning like addition, multiplication, subtraction, division, nothing more complex, but I didn't need a calculator at all. And they did offer to loan me one while I was there. The test can take up to 2 hours, but I only needed like 45, 50 minutes to actually take it. It's 63 or 64 questions and you need to get 70%. Multiple choice test. They give you 3 multiple choice answers. So 1 correct answer, 2 wrong answers, which makes it actually pretty easy. And I found that there's always one distractor, 1 wrong answer that's super easy to eliminate. So even if you don't know a question, there's pretty much a 50-50 chance that you'll guess it right. I've taken probably in the ballpark of 40 different types of certification exams in my life. And I think this was the single easiest one I've ever taken. Nonetheless, there's a lot of weird information to go over. So I'm going to try to just give you all of that information. This is not how I'm going to teach you to fly drones safely. This is how to get you through the test. Check our channel. We have a whole bunch of videos that can help you like properly fly drones and choose between different models of drones and get great photos with drones, that type of thing. This is for the certification test. This is the question you're going to be asking yourself frequently as we go through the material and as you take the test. Why the hell am I learning this bizarre information? Why do you want me to know the Class B ceiling of a particular airport when I can't fly over 400 feet and I definitely can't fly near an airport? Why do I need to know how to read these bizarre 1950s weather reports when I could just open up a weather report on my phone and get way more detail? I know. I'm not the one making the test. I'm not the one saying that this is important for you. That's the FAA. But think of it this way. You get a glimpse into this long history that the FAA has of providing really safe air travel. It will give you an appreciation for what pilots go through and an appreciation of the greater airspace in the United States. You will be a pilot. You will be an airman. Granted, it's a remote pilot, but you will have a glimpse into that world, and it's fascinating and it's historic. I found the whole process fun. So you often think that this isn't that practical. Nonetheless, it's cool, and if you want to do this professionally, it's absolutely necessary. If you want to actually learn how to fly a specific drone, visit this link, sdp.io/tutorials. We're putting up tutorials on how to like the mechanics of the drones and stuff. Again, this is different. And this link, sdp.io/drone, goes to our overall playlist with all of our drone videos. First, let's go over various laws. I could have called this section numbers, because I'm just going to give you a bunch of numbers and then tell you the importance of it. This kind of makes it easier to remember. This is like flashcards. So our first number is 0.55 pounds. That is the minimum weight that a drone would have to be before you need to register it in the United States. All drones basically have to be registered with the FAA unless they're under this weight. That's a really light weight. Even this Mavic here is over half a pound. The maximum weight, 55 pounds. So just remember 0.55 to 55 pounds. They made that pretty easy. A 55-pound maximum UAS unmanned aircraft system, a drone. Above that point, it's not considered like a legal drone anymore. It's too heavy. You could do even more damage than would otherwise be allowed. 13, that's the number of years of age you have to have in order to legally register a drone. So if you're 12, you can't register a drone. You'd have to get your parents to do it. Here's a question. As we go through, I'm going to be showing questions that are taken from the FAA's sample test. However, these questions pretty much exactly appear in the test. It's not all of the questions that you'll get on the test, but a lot of them will be going through. The first one, under what condition would a small UA, unmanned aircraft, not have to be registered before it is operated in the United States? And the answer is A, when the aircraft weighs less than 50.55 pounds on takeoff, including everything, including the battery. So you might see an answer that tries to trick you, like they'll say 0.55 pounds without the battery. Of course, it includes everything. One thing I found about the test is the distractors, the wrong answers, are often not very good. So you can, if you're a logical person, you can kind of think about these questions and figure out which ones of them are wrong. Another related practice test question, according to whatever part of the law: when must a person register a small UA with the FAA? Again, when it weighs greater than 0.55 pounds. That's an easy one. Get another sample test question on the same topic. You'll see a lot of questions hitting the same point over and over again. When would a small UA owner not be permitted to register it? When they're less than 13. Again, 12-year-olds can't register it. You can take the test when you're 16 years of age or older. And the test, if you pass it, it will remain valid for 2 years, for 24 months. Just want you to memorize these numbers for the test. Make sure you know all of these numbers. Another good number to know is 400. You're going to see 400 a bunch. 400 feet above ground level is the altitude you can fly your drone at. You cannot fly it to 401 feet. If you have one of these DJI drones, you probably already know this number, because if you accidentally try to fly too high, by default, it will stop you. Here's a test question about that same topic. To avoid a possible collision with a manned airplane, you estimate that your small UA climbed to an altitude greater than 600 feet above ground level. So they're saying in this scenario, a plane was coming at you or something, and you decided it was wise to fly up to 600 feet, breaking the law. To whom must you report the deviation? The answer here is C, upon request of the FAA. Air traffic control would never ask you to report something. The NTSB would never ask you to report something. The TSA will never ask you to report something, nor will the Department of Defense. These are all things you might see as distractors. The only person who you will ever report to is the FAA, and you don't actually have to report flying over 400 feet if you do it to avoid something. They don't want to be bothered with lots of little reports like that. Only if it becomes news and they say, hey, make a report on this, will you have to report it. So it's important to know it's okay to fly over 400 feet if there's an emergency, if you have to take evasive action or something. 400 feet above or around buildings. So if there is a building that is 10 stories high, maybe it's 100 feet and you need to fly above it, maybe for aerial photography, you could fly up to 500 feet. If you're taking a picture of a 1,000-foot building, theoretically, you could fly up to 1,400 feet. You can fly 400 feet above buildings within a radius of 400 feet around it. 400, 400, 400. Now we get into the 500s. A couple of the numbers you need to remember are 500s. You need to be 500 feet below the clouds. So if you look at your weather report and you find out that the cloud ceiling is at 600 feet, that means you'll only be able to fly up to 200 feet. If the cloud ceiling's at 1,000 feet, well, you're still at 400 feet because you can't fly over 400 feet anyway. So what if the cloud ceiling's at 800 feet? How high do you think you could fly? 800 minus 500 is 300. Horizontally, you have to stay away from clouds too. I guess there would have to be a cloud in the altitude that you'd be able to fly. Let's say there was cloud cover at 300 feet. That's possible. You'd have to stay 2,000 feet away from it, horizontally. You'd also have to stay 2,000 feet away from guy wires. I know, I'm throwing a lot of numbers at you. I'm doing it fast. You're probably gonna have to watch this stuff more than once to absorb it. That's okay, take your time, go through it as many times as you need to. 100 miles an hour, that is the maximum legal speed of a drone without getting some kind of waiver. Most of these rules can be broken if you write to the FAA. If you ask them to give you a waiver, they can give you permission for these kinds of things. 3, SM visibility. SM is statute miles. That's how you're usually going to see distance measured in either nautical miles or statute miles, but most of the time it's going to be SM. That's how far you need to be able to see to fly your drone. They kind of measure visibility, based on if there's a lot of haze or fog, your visibility is going to drop down, and they don't want you flying unless the official visibility is 3 miles. Now that doesn't mean you can fly out 3 miles, because you have to maintain visual line of sight. You have to be able to see it, and you certainly can't see it at 3 miles away, even if you have 3 miles of visibility. But they want to be sure that you could see an airplane coming in that was 3 miles away, so that you would have plenty of time to avoid it. 3 statute miles. Remember that. 8 is the number of hours that you have to go between having a drink and flying your drone. So if you go out to a lunch picnic and you have a beer, and then a couple hours later you want to show off your drone to your buddies, that's not legal. You have to wait 8 full hours. Another number you need to know, 0.04. That's the legal blood alcohol level. Maybe 8 hours ago, you got super tanked, and then 8 hours later, you still have a 0.05 blood alcohol level. First, my hat's off to you, but you still can't legally fly that drone. You got to wait for your BAL to come down a little bit. And if you get convicted of some sort of narcotic thing, like you're growing marijuana or something, you have to wait 1 year after that final conviction. Not when you get arrested, but your final conviction. 1 year, that's the number I want you to know. You can fly your drone before sunrise or after sunset for a period of 30 minutes. So 30 minutes before sunrise, 30 minutes after sunset, that's in twilight. But in that condition, it requires your drone to have anti-collision lights that can be seen from a distance of 3 statute miles. And no, your drone doesn't have those lights on it by default. You can buy some super bright LEDs that have little batteries and rig it up on your drone, and that will probably meet that requirement. But these drones have lights, but they're not powerful enough to meet this requirement. So just remember, 30 minutes before sunrise, after sunset. Here's a question about that. According to laws, what is required to operate a small UA within 30 minutes after official sunset? A, the use of anti-collision lights. $500. That is the limit that the FAA draws before you have to file an official report about an accident. And that is not counting the cost of your drone itself. So if I crash this very expensive Inspire into a building and the building is unharmed, my Inspire is trashed, it's a couple of grand, but I don't have to file a report. If I crash it into somebody's Lexus and I break the windshield and that windshield costs $600, at that point I have to file a report with the FAA. And another number you should remember is 10 days to file that FAA report. You have to file it within 10 days of the accident. The only other time you have to file an FAA report is if somebody is injured. Not the only other time you have to file a report, but another time you have to file a report is if somebody is seriously injured. Not scraped, not they were scared or dazed or whatever, but what they call like seriously injured, like they might have to go to the hospital or something, then you'd have to also file a report. Those are most of the big numbers you have to memorize. I have a hard time remembering facts like that, like just numbers. So what I would suggest doing is getting my study guide. It has all those numbers written down, and then right before you go into the test, review those numbers, get them stored up in your head, and then when you sit down at your desk, pull out the pencil and piece of paper that they give you and write down the numbers. That way, even if you can only keep it in your head for like 10 minutes, you'll still be okay. Let's talk about different airspace rules. This gets weird. You probably heard your pilot when you're sitting in the back of Delta. They'll be like, "Oh, we're now entering Class B airspace." Let's find out what all that is. Here's a diagram from the FAA. At the top, you have this big Class A airspace that pretty much covers everything from 18,000 feet up over the US. And this is when you look up and you see airplanes like going overhead, even if you're out in the wilderness, that's because they're flying in Class A airspace. That's where airliners are going. That's sort of long haul stuff. As you get around airports will start to claim different sections of airspace below that point. They won't go into Class A airspace no matter how big the airport is. The lower the letter, the bigger it is, really. So Class B airspace is for major airports, something like JFK, LAX, Boston. These are Class B airspaces, and they call it an upside down wedding cake because it has these tiers that get smaller at the base. So this kind of makes sense, right? And think about how airplanes land. They start up high and then they come down. You want to be sure that whole airspace is cleared so that other stuff isn't getting in the way of these airplanes. When a pilot comes into Class B airspace, they need permission to enter that airspace. So they'll call the air traffic control and be like, hey, can I come into Class B airspace? And they'll be like, yes or no, you can or can't do that. And of course, they'll come down. Class B is for the biggest airports. It covers the biggest space. It has those like 3 tiers traditionally. Those tiers can change shape. We'll look at maps in a little bit and kind of get a better sense for how big those tiers are. Class C airspace is for smaller airports, like regional airports, like in this area, it might be like the Bradley Airport. You probably don't know that. And it typically has these 2 tiers, one small tier and then one bigger tier. And then Class D airspace is for kind of really small airports. They might not have a tower at all. And Class D airspace, you'll be, when you start to look at maps, charts, you'll be shocked at how much of the world, how much of the continent is covered in Class D airspace. There are places where like everything is covered in Class D airspace, which is a pain because you cannot legally fly your drone in Class D airspace, well, without ATC permission, without air traffic control permission. And this is what you really need to know for the test. If you're in any of those airspaces, except for like Class G airspace, which is just general airspace, or Class E airspace, you can fly in those. But if you're in Class B, C, or D airspace, or Class A airspace, you can't fly your drone in there, okay? You're probably not gonna get up into Class A airspace, so I wouldn't worry about it. Well, you could fly your drone if you had permission from air traffic control. So that's the answer. Here's a sample question. According to some law, the remote pilot in command, that's you. You'll see this a lot. PIC, remote PIC, that's just you. You are flying a small unmanned aircraft and you're planning to operate within Class C airspace. What do you have to do? Do you have to use a visual observer, which is somebody who's helping you out watching it? No. Are you required to file a flight plan? No. Are you required to receive ATC authorization? Yes, you just need permission from air traffic control. Real world stuff here, you can no longer just call air traffic control as a drone operator. You're not allowed to do that. Instead, you have to go to this FAA portal online and request a waiver and then ask the FAA for permission, and the FAA will kind of interface to that airport and ask if it's okay for you to fly. You have to give them 90 days to get a waiver. So remember earlier when I said Class D airspace seems to cover most of the United States? That means you would need a waiver to fly in any of that Class D airspace. And to fly it, you would need to file it 90 days ahead of time and get permission. Not everybody gets permission to fly in this Class D airspace. And then what, 90 days later, it might be raining or something and you can't do it. So the process right now is a pain, but the FAA is working to kind of smooth it out. Here's another sample test question. You've been hired to inspect the tower under construction at an airport at a particular coordinates. What must you receive prior to flying your unmanned aircraft in this area? Authorization for the military? No. Remember I told you all these groups that won't give you authorization? Not the military, not the National Park Service, even if it's in a park, even if it's in a military operations area. They don't want you calling the military or calling the Park Service. You need permission from the air traffic control. And the way you do that is through an FAA portal, but I didn't get questions asking me about the portal, just that I need permission from the ATC. According to another law, how may a remote pilot operate an unmanned aircraft in Class C airspace? Okay, starting to see a trend here, right? The remote pilot must have prior authorization from air traffic control. They're going to try to trick you. Do you have to monitor the ATC frequency? Do you have to contact ATC? No. You have to have authorization from ATC, the air traffic control. Let's talk about radio stuff. These FAA guidelines go way back before apps and web services and stuff, when you'd like talk into your radio like they do on, Top Gun to get, that's just how stuff works. So let's talk about what the different terms mean. The CTAF, you'll see this term a lot. It's used for pilots to self-announce. Most of the time when we talk about CT, it's like a pilot can announce that they're coming down for landing or they need clearance or something. Most of the time, I'll show you in a map later how to find CTAF frequencies. The questions you'll see around CTAF will be, what is the frequency for this particular airport while you're looking at a chart? So I just wanted to review the term. Multicom is what you do when there's no CTAF frequency. It's just basically these kind of reserved frequencies that pilots can use for really the smallest of little kind of dirt airports and stuff. Like little small airports will use multicom, and just know these two numbers, 122.9 or 122.95. That's for multicom. Unicom is often the same as CTAF, rather than just everybody kind of communicating to each other. We'll cover it a little bit more in a second. And if you see the term AWOS, that's for weather broadcasts. I'm gonna take a minute and just ask you to do a couple of things for me. I'm dumping out a lot of information here. I'm definitely gonna throw out my voice while doing this long thing. Subscribe for me. I will have lots of videos about drones, using your drones, reviewing drones, as well as how to get awesome aerial photography. This is primarily a photography channel, but we also cover the usage of the mechanics of it, as well as how to do things well and get great pictures out of it, and kind of the business of being a professional photographer, and drones are a big part of professional photography. I'll also take a second and plug my books, like my book, Stunning Digital Photography, which will help you get awesome pictures with your drone, because believe it or not, it's not about getting a certification or learning to fly. If you want to get great pictures, you have to understand lighting and planning and composition, the art of photography, which has been around for a long, long time. I teach that with video. In case you hate reading books, you can just watch the 14 hours of video in Stunning Digital Photography. Now, it's the number one best-selling book in the world. Go to Amazon, look up Tony Northup, and you'll see all these books. Or if you want worldwide shipping, go to sdp.io/store. The ebooks start at $10. The paperback books are like $20 or more. You might also want to check out books on Lightroom, which helps you organize your photos and do light editing, and Photoshop, which will teach you how to really get your pictures just perfect. That's important. Even if you're doing realtor photography or some other type of commercial photography, you're going to need to know those things. Let's talk about radio talk. You've heard it, because I know you're like me. You've watched Top Gun like 17 times, and they talk like this. So you're familiar with it. Like they won't say just I'm on frequency 129. No, they'll say 129er. You need to be able to recognize these for the test. I had a question kind of covering these things. So the FAA wants you to be able to listen to the air traffic control and be able to communicate with them, even though you're not allowed to call them. They want you to know this. So I'm going to quickly go over their fancy ways to say every letter. You've probably heard these, like Alpha, Bravo, Charlie, Delta. That's A, B, C, D. The reason they do this is they need to be crystal clear when they communicate on kind of old-timey radios, which might have static. Like these are analog radios, which can have some kind of interference. So if you just say, I'm on ABCD, did you say like D or B? You know what I mean? It can be hard to understand. But if you say Bravo and Delta, there's no doubt which of those two words you said. So it adds clarity, and you don't need to be able to talk perfectly in this pilot language. But you do need to be able to recognize the real and fake words. So you might see on the test, Alpha Betty. It's not Betty, it's Bravo. So I'm just gonna read these to you, and that's probably gonna be enough for you to recognize the words that are valid and are not valid. Remember Niner, Alpha Bravo, Charlie Delta, Echo Foxtrot, Golf Hotel. India Juliet Kilo Lima. Mike November Oscar Papa. Quebec Romeo Sierra Tango. Uniform Victor Whiskey X-Ray. And the last two, Yankee and Zulu. You'll hear a lot of these in movies, and they will usually pick the coolest sounding one. So they'll say Zulu a lot and Victor a lot because those are cool sounding words. They'll say whiskey a lot too. You won't ever hear them really say Quebec. Quebec just doesn't sound as cool as like Alpha Tango Whiskey Foxtrot. Okay, let's talk a little bit about physics, because the FAA wants you to know the basics of, mostly like plane physics handling. And this is one of those times when you're going to be asking yourself, what the hell is this about? Why do they want me to know about the stall speed of a fixed wing aircraft when I'm flying a quadcopter? They just do. Okay, so let's talk about stalls. If plane's going along and it's loses speed, or if it pitches up too fast and it doesn't have enough speed, it stalls, and suddenly it loses lift and it will just flop down like that. Stalls are bad. The key thing you need to know about stalling is it happens when the plane exceeds the critical angle of attack. If there's something impacting the plane that would make the situation worse, like maybe you're banking heavily or something, it's going to increase your stall speed. I just wanted to point that out because it sounds a little counterintuitive. Like, it sounds like increasing your stall speed is a good thing, but that means that you stall when you're going too slow. So instead of having your stall speed at 100 miles an hour, if you increase your stall speed, it means you'll actually stall at 150 miles an hour. So increasing your stall speed makes things more dangerous. Here's a question related to that topic. A stall occurs when the smooth airflow over the unmanned airplane's wing is disrupted and the lift degenerates rapidly. This is caused when the wing exceeds its critical angle of attack. Now, there's a lot of information just in that question, and this tells you a lot about what the FAA wants you to understand in this test. Like, they could have just said what causes a stall, but they put all this information in the question itself about lift degenerating because they just want you to appreciate the complexity of airplanes and how everything works. There's unnecessary information in that question that tells you something. The load factor is basically how much pressure is on an airplane. Now, if it's in a heavy bank, of course, that's adding some G's to it, right? You're putting more pressure on it. And they want you to understand that. It increases during turns, and that can cause the plane to do some erratic stuff. You might exceed the load factor for the airplane if you have a bunch of weight on it and you're banking heavily, something like that. It's not likely to happen in a quadcopter scenario, especially because you're not really adding extra weight to most quadcopters, nor are you kind of banking like that. But they want you to understand that and be able to calculate the load factor on mostly fixed wing aircraft. So you'll see this little chart here, and if you get a question about it, they'll show this chart to you, and then they'll also show you an index that says, say, a bank angle of 60 degrees will give you a load factor of 2. What this means is, let's look at a sample question about this. When operating an unmanned airplane, the remote pilot should consider the load factor on the wings. Consider that the load factor on the wings may be increased anytime the center of gravity is shifted rearward to the aft CG limit, the airplane is subjected to maneuvers other than straight and level flight, or the gross weight is reduced. So this is one of those questions where you can easily eliminate one of them. Like, you know for sure reducing the weight of an airplane isn't going to increase the load factor. Like, even if you don't know anything about this, you could figure that out just by reading the question. So when you're in doubt, read things through carefully. In this case, the load factor is increased by any sort of maneuvers. Another question, if an unmanned airplane weighs 33 pounds, what approximate weight would the airplane structure be required to support during a 30-degree banked turn while maintaining altitude? A lot of information there. The key numbers are the airplane weighs 33 pounds and a 30-degree banked angle. So let's go back to our chart here. And as we go back to the chart, so you'll look at 30 degrees and you'll go up here and you'll see it's at like 1.1. And there'll be a chart too, so you won't have to use this visual diagram. You'll multiply 33 times 1.1, and that will get you to about 38 pounds. You know, it would have to be like 1.5 to get to 47 or something less than 1.1 to get to 34. This is like the one time you might need that little 4-function calculator, but depending on how good you are at math, it might be easier than that. The center of gravity. Of course, we all have a center of gravity. If the center of gravity is way at the back, everything like leans back. If the center of gravity is way forward, everything kind of leans forward. Planes have a center of gravity too, and how, depending on that center of gravity, where it's positioned, it might cause the plane to lean back or to lean forward. And, you know, again, with this type of quadcopter that most of us are going to be using, you're probably not shifting the center of gravity around. Maybe if you have an Inspire and you stick a big heavy lens on it or something, you might shift the center of gravity, but even then you'd probably recenter it. Changing the center of gravity beyond the limits that the plane was designed for will negatively impact the handling and maneuverability. And that's what you should know. And that information about the allowable center of gravity, whether it can be so much farther forward or so much further aft, that is supposed to be defined in like the UAS flight manual. This is stuff that doesn't exist except in FAA theory. Now I have never seen any drone manual that says anything about center of gravity, but it exists in the FAA universe and they want to test you on that. So here's a sample question. To ensure that the unmanned aircraft center of gravity limits are not exceeded, follow the aircraft loading instructions specified in the Aircraft Weight and Balance Handbook. That doesn't exist. No, it's the Pilot's Operating Handbook or UAS Flight Manual. Now you might be looking at those answers being like, I haven't seen the UAS Flight Manual. Again, doesn't exist. Fine. Okay, sectional charts. Man, hit pause, get yourself a cup of coffee or something, because these sectional charts are going to blow your mind. If you love great design, this might make you want to drink. Here's what a sectional chart looks like. And this is such a small piece of this. The sectional chart is actually a really big, massive, and scary piece of paper. We have one for this area, and it's absolutely huge. And as you look at it, it is so cluttered with information that it's almost impossible to discern what the hell is going on. And that is the key challenge in this part of the test, is just discerning their just really old and terribly formatted sectional charts. I suggest you get the chart for your region. You can download older charts at sdp.io/chart. All like real pilots are required by law to carry one of these things around, and we do have a physical one. It's cool to have. You can just pretty much go on and buy one on Amazon or something, or stop by an airport in your area. They'll probably be able to sell you one. First of all, these sectional charts have a legend. And when you're taking the test, they will give you the legend. The legend tells you just about everything you need to know to get all those sectional chart questions correct. This is great news, because understanding these charts is a freaking nightmare and requires you to memorize lots of stuff, except you don't have to memorize it because of the legend. So let's look at the first part of the legend here. As we look at this, you can see they're telling you lots of things. They're showing you some diagrams of the airports here. They're telling you what, like, circle on an H, it's a heliport. And they're also telling you what, this is something you're more likely to see on the test, is the airport data. So over each airport, there's going to be a little diagram that has some of this information, not necessarily all this information. They don't put it there for everything, including like the code for the airport and the frequency for the airport. Look, if you're wondering what Unicom is, they might ask you what the Unicom frequency for an airport is. The legend will tell you Unicom and then point to an arrow that shows you the right number. So you might be feeling overwhelmed when the test asks you to find the Unicom for an airport. take a deep breath, look at the legend, and then just match it up. So you don't necessarily have to remember which of that mess of numbers is the Unicom. All of those different numbers are explained in the legend, so you don't have to memorize that. Here's another part of the legend. For example, this legend tells us that the blue lines here indicate Class B airspace, the magenta lines indicate Class C airspace, and then the dotted blue lines, Class D airspace. They tell you what the number in the box means. That's the ceiling of the Class D airspace. You can see Class E airspace for really small airports is in like this dashed magenta here. All those crazy lines, if you're wondering what they mean, come back to the legend. If you forget the difference between blue and magenta, as any person would, come back to the legend and you can see. There's a whole section here on the different towers and exactly what that means. You can see that they even tell you that this first number here actually means above sea level, while the second number in parentheses means above ground level. So even if you forget everything I taught you about charts and you get there, take some time and look at the legend and just refresh your memory. Let's take a look at what airspace looks like on a chart, how these, what they call sectional charts. I would call them maps, they call them sectional charts. Airspace indicates. Okay, so this is kind of my local area here, and the Groton Airport is here. And if you're wondering about the airspace, look, there's a dashed blue line right through here. And maybe you've already forgotten whether a dashed blue line is B, C, or D. Again, go up to your legend here, and here you'll see a dashed blue line is Class D airspace. See, you don't have to know anything about the chart. You can already figure this stuff out once you know how to piece it together. What frequency do you need if you want to contact the Groton Airport and you're in an airplane and you have a radio and you're not flying a drone because it wouldn't be legal, but they'll want you to know how to do this? Well, it's going to be the 125.6, but if you were confused about that, again, you could just look at it. What does the number 25 in the box mean there? See number 25 in a box? If you're not sure what that means, go back, look at the legend again, and you'll see, like, they have an example here, number in a box. That's the ceiling of the Class D airspace in hundreds of feet. So the number 25 in a box, that means the ceiling of the Class D airspace is 2,500 feet. The top of it. Meaning if you were a private pilot in like a manned airplane, you could be cruising along at 2,600 feet and not have to call in for permission to enter. That's what that number means. I know these charts are overwhelming, but I promise if you take it and you look at tiny small pieces of the chart and you refer to the legend, you can make sense out of it. Even full-blown pilots with many years of experience are frustrated and confused by the maps. So if it feels overwhelming, I get it. This is the Boston area, Logan Airport. And what you'll see here are concentric blue circles. Remember when I showed you that chart of the upside down wedding cake? That's what these are indicating, the different altitudes of the Class B airspace around Logan. You'll see some numbers here, 70 over 30. This is the upper and lower limit of the Class B airspace. It's not 70 feet and 30 feet. No. The FAA has decided to drop 2 zeros from the numbers. So 70 means 7,000, 30 means 3,000. They often do this, so they will never drop 3 zeros or 1 zero. They will always drop 2 zeros if they're dropping zeros. It is a weird standard that you don't really see in other places on the planet. Like they could drop 3 zeros and put a K there and call it like 7K over 3K, and that would make sense to most humans. But the FAA has their own kind of way of doing this, and it's worked out great for a long, long time. If you look closely at this, you can actually see a little diagram of what the runways look like at Boston Airport. And you can see that, oh, there are some little mountains here. If you were to look really closely, you could see the exact elevation of these different peaks. All the information is there. The hard part is weeding out the information you need from the stuff you don't necessarily need. Here's a super close-up of those numbers, and this is how you need to think about the charts. You need to look really close. When you get this close, it can start to make sense and not be overwhelming. Here's a question from their practice test, but it's just like you'll see on the real test. What is the floor of the Savannah Class C airspace at the shelf area, the outer circle? And then they're going to give you three numbers, 1,300 feet. And in this particular question, you'll probably see maybe it'll be 25 over 13. 25 would be the ceiling of the Class C airspace, and 13 would be the floor of the Class C airspace. Because remember, it's like a tier, it's floating out there. These numbers are always above sea level, which is MSL, not AGL, which is above ground level. If you have a hard time remembering if it's sea level or ground level, well, the legend tells you that, so you can refer back to that. You can also think back to the history of the FAA, because the FAA was founded before like proper computers and electronics and GPS and stuff. So somebody in an airplane, they could have an altimeter, which would use barometric pressure to kind of determine what their altitude was based on the air pressure. But of course, that altimeter would only know above sea level. It wouldn't be able to tell if you were flying over a mountain or something. So modern GPS could figure out above ground level, but these older airplanes could only determine sea level. So of course they're going to write on the charts the altitude above sea level. So right away you can eliminate AGL, and then you just have to look, does it say 13 for 1,300 or 17 for 1,700? Let's look at another close-up. This is an extreme close-up of a red flag. That red flag is important on the map. That indicates a VFR checkpoint. VFR stands for Visual Flight Rules. This is like a little beacon that pilots could use during navigation. Again, kind of heralds back to days before complicated GPS and stuff. What they want you to know about these red flags is planes might use them as beacons, and therefore there might be more planes in this area. The planes probably aren't going to be flying below 400 feet, but they want you to know this because they're really concerned about drones flying into airplanes. Here's another super, super close-up of a tiny, tiny section of a map. I just wanted to show, in this particular example, you can see 41 over SFC. This means the ceiling of the airspace is 4,100 feet. You want to add two zeros, and then SFC stands for surface. You can see a little map of the airport there. Look, that little dot, it's got a tower. So you can see exactly which direction the runways are pointing in, and there's lots of information about like the nearby peaks, that kind of thing. Let's take a look at another close-up here. Here, well, we do have a tower here, and you can see it even says the name of it. Here's something else, and this is the altitude, and this is above sea level, and then 233 is the altitude above ground level. So they're telling you both the altitude of that tower above sea level and above ground level, so you could use either. You could also subtract those two numbers and figure out what the altitude of the ground level was at that particular point. It would be 513 minus 233, so what is that, like 280 would be the altitude. Those don't have the two zeros there. That tower is not at, 51,000 feet. Here's another interesting marking. See the little parachute dude there? That means that there might be skydiving in there. It might just be recreational skydiving out of this particular airport. That's the kind of thing that's actually kind of practical. You should know if there might be skydivers in the area, because skydivers will pass through that space from 0 to 400 feet, and you don't want to crash into them. That's one of the reasons you really need to be keeping your eye out. Don't fly your drone into skydivers. More icons here. Here, this particular airport has skydiving, and it also has gliders. And they just draw a picture of a glider. You can also see, look, there's the Visual Flight Rules little beacon there, as well as all this information about this, pretty small airport. So here's a question about these charts. With ATC authorization, in this imaginary world where you could actually get authorization, you're operating your drone approximately 4 statute miles SM southeast of this airport. Which hazard is indicated in that area? High density military operations in the vicinity, an unmarked balloon on a cable, either above ground level or above sea level. Again, it's probably going to be above sea level. And in this, I'm not showing you the right chart, but you'll see a picture of a balloon when you look at this particular one. Just know that when you actually find the location on the chart, there's going to be a picture of a parachuting guy or a balloon, and sometimes there'll be a note that just says the balloon. I'll give you links to these practice tests so you can actually take them. I don't want to give away the answers to the actual practice test so much because I want you to actually work through it. So at another airport, which frequency should be used for CTAF communications? If you're like, how do I know which of those numbers is CTAF? Come back to your legend. See the legend says follows the common traffic advisory frequency CTAF. It indicates this little C. So you can just look at the airport data. See this C? That means that it's this number here. And the star here indicates that it operates only part-time. It's all in the legend. You might have been tempted to look at this number. That's the ATIS, the Automatic Terminal Information Service, which might have information on rental cars or whatever. So when in doubt, go back to that legend and just make sure that you're looking at the right number. Let's move on. Okay, you'll see these like kind of blue paths here. Those are just indicating frequent flight paths. And all the FAA wants you to know about these is that there might be more airplanes in there. They're not going to be flying under 400 feet in all likelihood, but they want you to know to just use extra caution. Let's talk about prohibited areas. These maps will have lots and lots of prohibited areas and military operations areas, lots of places either you shouldn't fly at all or you should use caution around. And the prohibited areas, you just shouldn't fly. And this is the one from the FAA samples, but it's actually indicating Camp David, where presidents like to vacation and stuff. So they don't want any air traffic over this place. Restricted areas are not as restrictive as prohibited areas. They have different types of rules and stuff. And here's a sample restricted area. Again, the legend will tell you that these like blue lines with the lines here indicate a restricted area, but they also tend to just write it out. There's numbers here that start with the R and then have a code. If you look at your sectional charts, over in the bottom or the margin of the sectional chart, there'll be some notes about when exactly it's restricted. Usually there's some sort of hours. And I think the test will even ask you to look up a phone number there. I don't actually see any phone numbers in my sectional charts, but they will have frequencies where you can listen to get some information about whether it might be in use or not. Specifically, the FAA wants you to know this language about restricted areas. Restricted areas denote the existence of unusual, often invisible, hazards to aircraft, such as artillery firing, aerial gunnery, or guided missiles. Restricted areas. Just want you to associate in your mind that language. Let's talk about the MOAs, the military operation areas. Here's an example of the military operation area on a map. These are places where, people might, the military, Air Force, Navy, anybody with planes might be flying exercises, used to live in an MOA. It's not like they're deserted areas. They can have, towns and neighborhoods and stuff. And when the military would be doing exercises, I'd get weird, huge dual rotor helicopters or a convoy of massive cargo planes coming in at 600 feet and just causing my whole house to shake. These MOAs are kind of all over the place, and it doesn't mean you can't fly in an MOA, but the FAA wants you to exercise extreme caution, of course, because it really can be dangerous, and they really do fly very low often, and to just check the information in your chart or your sectional. We'll talk about those docs in a little bit. Military training routes, which might be indicated with the letters MTR, IR, or VFR. Here's an example of what they look like on a map. This is the FAA sample. You can see this particular one shows IR 037. And that's just an example. You might also see it indicated as VR, not VFR, but VR. Here's a sample question related to it. The chart shows a gray line with VR 1667, VR 1617, etc. Could this area present a hazard to the operations of a small UA, unmanned aircraft? in general, they're not going to present you a question and the answer be like, no, you're fine, just do whatever. They're always going to present hazardous situations. So right away, we could pretty much eliminate no as an answer, even if we had no idea what it was talking about. In this particular case, the answer is B. Yes, these VR lines indicate military training routes that go from the surface to 1,500 feet above ground level. We know it's 1,500 feet because it's a 4-digit code. You probably won't need to know that in the test. Either way, it goes down to ground level, and that indicates that planes really might be flying under 400 feet, so it really could be an issue for you. Let's talk about the difference between latitude and longitude. You're going to nail this because you went to the 3rd grade, so you probably already do know this, but if you forgot, latitude goes north and south, like climbing a ladder. Longitude goes east and west around the Earth. It's long because the Earth is kind of fat because it spins and stuff spins to the outside a little bit. Latitude, north and south. Longitude, east and west. You need to know that, and you need to be able to find specific latitudes and longitudes on a map, on their sectional charts, on their crazy sectional charts. It can be difficult for your eyes to actually find the latitude and longitude numbers. So I'm showing this close-up of one section of a sectional chart that shows a latitude and longitude over the ocean, so there wouldn't be so much clutter. But you can see 41 degrees. Do you think this is indicating latitude or longitude? The answer is latitude, because this is indicating how far north it is of the equator, 41 degrees north of the equator. So what do you think, if we were to scroll up a little bit, what do you think would be up there? Would it be 40 or 42? The answer is it would be 42, because 0 latitude is on the equator, and then the numbers go up from there. All the examples are going to be in the northern hemisphere in all likelihood. 70 degrees here, that's indicating the longitude east and west, 70 degrees west of like Greenwich probably. And so as we go west, as we go to the left, those numbers will increase. So the next one to the left would be 71. You can think about it this way. It's weird that the numbers get higher from right to left instead of from left to right, since we read that way. But think of it as the United States was settled by the Europeans in the east, and then we worked our way west. Like the rest of the world might call the US the West. We're to the west, and stuff keeps getting higher as we go west because we count from the east. So as we look at this, you should know what these little tick marks mean. And each one of these tick marks is 1 minute, because this is how they measure latitude and longitude. It's 41 degrees, and then this is 41 degrees and 1 minute. Wait, I'm sorry. I said that wrong. This is 70 degrees, and this is 70 degrees in 1 minute, 70 degrees in 2 minutes, 70 degrees in 3 minutes. There's big tick marks every 5 minutes, and then bigger tick marks every 10 minutes. So if they ask you to find 70 degrees in 10 minutes, you'll start at 70. Remember, higher numbers go west, 70 degrees in 10 minutes, 70 degrees in 15 minutes. What if they ask you to find 40 degrees and 58 minutes latitude? That's going to be here, right? Because here's 41 degrees, so we just need to subtract 1, 2. So take away from this, numbers get higher the further you go north. North and south is latitude. East and west is longitude. The numbers get higher as you go west. Every tick mark is 1 minute, and you will be counting tick marks for some of the questions. Here's one sample question. Which airport is located at 47, whatever? They'll give you some coordinates like this, and you'll have to be able to go to the map and find that specific airport by just counting. Another question. What is the line of latitude at area 4 measure? You should know when you look at the sectional maps, they refer to areas just for the sake of the question. And so there'll be like a number 4 in a circle or a number 3 in a circle. And that makes stuff much easier to find. Because otherwise, if you don't know that trick, you'll look for the Chattanooga airport and you could spend 20 minutes trying to find some little spot. As soon as you know where the areas numbers are, it makes it much easier. But you can answer this question because what do you think a line of latitude would measure? Does it measure east and west or north and south? We just learned this, right? You climb the ladder, it goes up, north, which isn't really up, but that's how we draw it on a map. So it's not latitude, it's not the degrees of latitude east and west, latitude's north and south. So right away, we know it's going to be B. You don't even have to look at the chart. I just want to mention there's two types of north, true north and magnetic north. True north you could follow it and go straight to the equator. Magnetic north, those little magnetic compasses that the Boy Scouts get, they're not 100% accurate. And those were in a whole lot of airplanes. I mean, they're still in airplanes, but that's entirely what pilots used to have to rely on, is this true north. So it doesn't always point to true north. It can point in some other direction. This map from the FAA kind of shows you just how much variation there might be between true north and magnetic north. So you can imagine you could get yourself real lost if you're using your magnetic compass thinking that it's true north. So you will sometimes see the FAA differentiate between true north and magnetic north, but generally on those maps, you're looking at lines that indicate true north. Let's talk about airports. The FAA wants you to know a whole bunch about flying your drone at airports, even though it's illegal and you're probably not going to get a waiver to fly at an airport. They'll throw out scenarios where for some reason you've been hired to fly around an airport and get pictures of a control tower or inspect a control tower or something. And basically, they just want you, again, to appreciate the complexity of flying airplanes and have some respect for being near other airplanes. When an airplane's taking off or landing, that's its most dangerous time. And they don't want somebody crashing into a drone when they're trying to land because they could die. So they want you to have respect for that, basically. Even though you're just gonna stay away from airports, you're not gonna fly in them. So let's talk about runway patterns. Planes take off and land into the wind, generally. You can think about airspeed, right? Like if a plane were on the ground facing into 200 mile an hour winds, it could just put its flaps down and just take right off, because it's that wind coming at it that's going to generate lift, not the actual movement of the plane relative to the ground. So if you have a headwind, it means you can take off at a lower relative ground speed. Birds do this too. Birds will almost always take off into the wind if they have the opportunity, because it makes things easier. Likewise, landing into the wind is easier because you can maintain a certain amount of lift with a lower ground speed. So just remember, planes take off and land into the wind, and airports are usually, runways are usually aligned so that you'll be doing that into whatever the prominent wind direction is. Airplanes, when they're landing and taking off, generally circle to the left. So they'll take off and then circle to the left and come back around. If air traffic control says an airplane can't land right then, they'll be circling the airport to the left. This keeps everything orderly. That way one plane can be landing while another one is coming in behind it. If they miss a landing, they just go back around. It keeps people from crashing into each other head on. It's just this sort of convention. If you have a hard time remembering that they need to turn to the left, think about it this way. We're in the US. The driver sits on the left side of the car. Planes work the same way. You sit on the left side of the plane. It's easier to look out your left window than your right window, right? So that way you turn to the left because it's just easier for you to see the tower and the runway and stuff. That's why they turn to the left. Helicopter traffic tends to go off to the right, just to stay out of the way of the fixed wing aircraft. Runway markings. When you're riding coach in United and the pilot comes on and he's like, we're landing in runway 9er. What he's saying is he's landing in runway 9, but that number indicates the compass direction of the runway. So runway 9 is oriented 90 degrees. 0 degrees is north, 90 degrees is directly east, 180 is directly south, and then 270 is directly west. But they drop 10. So runway 27. Which direction do you think runway 27 is facing? It's west, right? Runway 18 is facing south. Whatever airport you're at, that's how it works. Runway 13 is at the plane coming in for a landing would be at 130 degrees, which is like southeast, basically. Let that sink in a little bit. Look at your sectional charts, figure out what's going on. There's going to be some questions, especially in the practice test, that will require you to understand that and understand that upwind is heading in that same heading direction, whereas going downwind means you're going opposite the runway direction, and you'll have to be able to kind of draw. You have a pen and paper. You have to be able to kind of draw a 130 degree runway and figure out what direction you're heading when you're downwind and left of the runway, that kind of thing. It's useful to be able to do that. If your mind works that way, that can be a pretty easy thing for you. If not, it could be a challenge. Definitely know your compass headings. 0 is north, east is 90 degrees, south is 180 degrees, west is 270 degrees. Here's a sample question. While monitoring some runway CTAF, you hear an aircraft announce that they're midfield left downwind to runway 13. You can see why you might want to draw this out, right? Where would the aircraft be relative to the runway? I didn't actually get one of these questions on the test. They're on the practice test. They're pretty confusing and completely impractical, since you're probably not going to be flying at a runway. But think of it one step at a time. Runway 13. What is the heading of runway 13? 130 degrees, right? And then on a compass, what direction would that be? 130 degrees, well, 90 degrees is directly east, which is this way on a video camera that's opposite my natural. So 90 degrees is here, 180 is here, so 130 is somewhere in between. It's going to be southeast. So if the plane were heading upwind, they'd be heading 130 degrees. They're heading downwind, so they're heading 360 minus, they're 360 degrees on a compass, 360 minus 130 degrees, which puts them at 230 degrees. So they're going, instead of going southeast, they're going northwest. So now we know the plane is going northwest. Okay, so let's just map this out so we can keep ourselves sane. 180 degrees is south. 0 degrees is north. I'm a photographer, so I'm using Photoshop for this. East is at 90 degrees, and then west is at 270 degrees. The runway is 13, so it's headed 130 degrees like this. Okay, these are my awesome drawing skills. So runway 13 is headed this direction, and the wind is, we know people are landing going from up here to down here, which means the wind itself is going in this direction, right? Because you always land upwind. So the question itself says that the plane is midfield left downwind. We know the plane is midfield left downwind, so it's midfield, so it's in this area somewhere, and to the left of the runway it's going to be relative to facing upwind. So you're facing this way, which means your left is over here and your right is over here. So now we know that the airplane is like right about here. And sorry about my drawing. And the question asks, where would the aircraft be relative to the runway? The aircraft is east. I mean, it could be northeast, but north isn't the option because that would be confusing. So it's actually northeast, but if anything, the aircraft is east. The theory that they want you to know is, like, you might be flying around where you're theoretically listening to this runway chatter. Where is that plane actually going to be, assuming you can't see it? Let's talk about the different documents that the FAA wants you to know about. They're going to ask you questions like, which document should you refer to for this and that? The first is the user manual. This doesn't actually exist in the real world because DJI, most of the drone manufacturers don't include the necessary information in their user manuals, but the user manual is where you'll look for things like the maintenance schedule and how to care for your battery. So just know you should look in your user manual if it only existed. The maintenance schedule, again, the maintenance schedule is something the manufacturer is supposed to provide for you in the user manual, and they don't generally. If they don't provide a maintenance schedule for you, you're supposed to make one for yourself. Even though most of these drones aren't really user serviceable, so pretty much you just use them and then send them back when they break or throw them out. They're not really maintainable. That's real world stuff though. The test is not necessarily testing that, it's testing theory. So under what conditions should the operator of a small drone establish a scheduled maintenance protocol? You have to establish it yourself when the manufacturer does not provide a maintenance schedule. You'll see people online trying to figure out what the maintenance schedule is for their drone after having looked this up, and most of the time the answer is just, you could just sell it. Generally they can last several years, and that means that the maintenance, there probably won't be any required maintenance before you upgrade to the next model or something, but it's like uncharted territory. No pun intended. Sectional charts are the answers to lots of questions about what you should refer to for information about like Class D airspace. We looked at sectional charts earlier. It's this sort of chaos. Sectional charts also have some information about MOAs and such, but detailed information about MOAs, military operation areas, protected areas, different airports is in chart supplements, and this is what a chart supplement looks like. It's got lots of pages here for specific airports and other protected areas that list just even more detailed. So the chart supplements, it's a book that has way more detail than you can find in that terrible sectional chart. Sample question: the most comprehensive information on a given airport is provided by, it's not the sectional chart, it's the chart supplement. The supplement is the one that provides that detailed information. Notices to airmen, we'll talk about in a second. Terminal aero chart, those don't have that sort of information. The notice to airmen, NOTAM. This has time critical stuff in it, like, when Donald Trump was elected president, that day, the FAA issued a NOTAM to not allow people to fly like over the Hudson River, basically around Trump Tower. And that includes you and your drone. So if you were used to flying in Central Park, it's possible that the NOTAM would have prevented that. And being aware of that might save you from being tackled by a Secret Service dude. NOTAMs are going to be the answers to lots of questions about timely stuff, emergency stuff. Here's a question: how would a remote pilot in command check NOTAMs as noted in the caution box regarding an unmarked balloon? If you need to check a NOTAM, where you need to go is to 1-800-WXBrief.com. Before You Fly is an FAA app, and it's useful, but for some reason it doesn't have NOTAMs in it yet anyway, and they don't want you contacting their district office to find out if information about a balloon, right? So just go to this website, 100WXBrief.com, and remember that. The meteorological aviation reports have weather information, as do the Terminal Aerodrome Forecast TAFs. And well, right now, we're going to go over what those different reports are. I just wanted to familiarize you with those terms and let you know that they contain weather information. If there's questions about weather, that's where you should be looking. METAR looks like this. This is what a METAR report looks like. Oh my God, right? This seems completely indiscernible, like one of those secret codes you would get in your cereal. But I promise we're going to go over it for just a couple of minutes, and it's actually going to start to make sense. First up, that first block, that's easy. That's just the type of report. No problem. The second block, that is the 3-letter code for the airport plus a K. So this particular airport, the code is GGG. If you ever fly out of John F. Kennedy Airport in New York, it's JFK. So their METAR would say KJFK. Remember LAX, the LA airport? KLAX. That's all it is. So far, we've gone through a good section of it. Those first two words are really easy to understand. This one, also easy to understand once you figure it out. That Z at the end, that means, we call it Zulu because we talk like pilots do. that indicates UTC time, like Greenwich Mean Time, like universal time, not local time to the airport, but UTC time. So this is a time code. The first 2 digits of that time code indicate the 16 indicates that's the day of the month. So this weather report was issued on the 16th day of the month. They don't put the month because you're not going to be looking at it if it's a month old, right? And then the next 4 numbers here, 1753, that indicates the time of day. They always use 24-hour time. So 17 is 5 p.m. So you better get used to this 24-hour time. Remember, you just have to subtract 12 if you're used to using the AM PM system. So the 16th day of the month at 5:53 p.m. UTC. The next word, auto, means that the report was automatically generated by some sort of weather station. It could also say COR, which would mean corrected. Just so you're familiar with it, you probably won't get tested on that particular bit of information. This mess of numbers and letters is the wind speed, and it's really easy to read once you understand it. The first 3 digits indicate the compass heading. It's 140 degrees, 140, 140 degrees. Again, which direction is that actually? It's southeast, because east is 90 degrees, south is 180 degrees, and it's somewhere in between 180 and 90, right? So it's southeast winds. The next 2 digits, 21, indicate the knots of the wind speed. So 21 knots. And then you see G26. 21 knots gusting to 26 knots. And they actually write KT here. And that helps you recognize that this is indicating wind speed because KT is the abbreviation for knots. So we can read that word as wind speed, winds at 140 degrees at 21 knots gusting to 26 knots. Here's an example of a test question where you might get asked about this. The wind direction and velocity at KJFK is from, and then you'll look at that report and you'll have to be able to figure it out. Another example, this is from a different report, but you can see here it says VRB. That means variable winds, which means they might be going north, they might be going south. It's kind of changing around, and usually variable winds are also low wind speed winds. So it's saying at 5 knots. Variable at 5 knots. Just a completely different report, so you have some sense for how they vary. If you see the SM there, that's indicating statute miles, the distance. And that is indicating your visibility, because you wouldn't measure wind speed and distance, right? You would measure visibility. So you can see at 3/4 of a mile, 3/4, like a fraction. I don't know why they don't write 0.75 or something, but for whatever reason, they decided to use fractions. Another example of a fraction, this means 1.5 statute miles of visibility. So both those, you're supposed to get 3 statute miles of visibility before you fly your drone. So this would indicate that you shouldn't be flying your drone in that kind of weather. And then here we have an indication of what the weather is actually like. I'll show you a chart that shows you what all these different codes mean. You don't necessarily have to memorize them, but it doesn't hurt to be able to recognize them. So I remember that TSRA indicates thunderstorms and rain showers. The BR actually indicates the mist. I'm going to show you an FAA slide that shows you what these abbreviations mean. So you can see, looking at this, TS, thunderstorms, RA, rain, BR, mist. If you go back, you'll notice the very first thing is a plus there. That plus indicates the intensity or proximity. So a plus TS means heavy thunderstorms with rain and some mist. I don't want you to necessarily memorize every single one of these codes. Especially in the real world, you'll be using some app or something to tell you the weather. Just be able to recognize the most common ones, like SH is showers, TS is thunderstorms, and you should be fine for the sake of the test. This next section indicates the cloud cover. And just like earlier, they're indicating altitude by dropping 2 zeros off of it. So this BKN means broken clouds, and then we're going to add 2 zeros to this number, 800, broken clouds at 800 feet. This means overcast overcast clouds at 1,200 feet. There's a 0 in there. 1, 2, add 2 zeros, 1,200 feet. The CB means cumulonimbus clouds, like those big puffy clouds. So they're indicating the type of cloud. And then the last digits here. This chart shows you what those different codes mean. BKN, broken. OVC is overcast. You might see scattered or few clouds, or you might see them saying clear skies, etc. This last section here indicates the temperature and dew point in Celsius. I know every other measurement has been in like feet and miles, but now we're switching over to Celsius. It's indicating the temperature is 18 degrees Celsius and the dew point is 17 degrees Celsius. The dew point is important to understand because you might, get like precipitation, water forming on your wings, stuff like that. So that's why they need to know that. If those are within 3 degrees, that indicates like a higher chance of like water forming on your plane, conditions that you might need to be concerned about. Whew. There might be more information in there, like RMK is indicating remarks, but you probably won't be tested on it. I just kind of wanted to cover the core stuff that's in those reports. So here's a question about the METARs. They'll show you a METAR and ask you what the current conditions are for that particular airport. You'll look at the airport code and have to look at the METAR and figure out which of multiple METARs applies to that particular airport. You'll just be looking for, in this case, KMDW, and then you'll have to be able to discern all of that. Remember, they add 2 zeros, so like 2 of these, like this one is clearly distracting you, trying to confuse you by thinking that the number 7 indicates 7,000 feet when you know they add 2 zeros, so it means 700 feet. And then beyond that, you just need to figure out whether it says 1.5 or 2 SM, and you can figure out which of those 2 answers is correct. The TAF reports, terminal aerodrome forecasts, are formatted very similar to METAR. So once you figure out the METAR reports, you can pretty much read the TAF reports, but they both suck to look at. It's like, unless you're a computer. The report starts with TAF. That indicates that it's a TAF report. So again, that part is easy. The next is the airport code, KPIR. In this case, again, all airport codes in these reports start with a K and then the 3-digit airport code. What does this mean? It's got a Z at the end, right? Remember what the Z means at the end? Zulu, UTC time. So we know that this is a time code. They use this weird format where the first 2 digits indicate the day of the month. So the 11th day of the month, and then 11:30. It's under 12, so that means 11:30 a.m. Look at this. That's when the report was generated. So the 11th day of the month at 11:30 a.m. UTC. And then the next phrasing indicates how long the TAF is valid for. This is telling us the weather, and then, hey, this report is good for this period of time. It's the beginning and end of the period of time that the TAF is valid for. So the 11th day of the month to the 12th day of the month. That's what this number means here. The 11th day of the month to the 12th day of the month, beginning and ending period at 12 o'clock to 12 o'clock, 1200 hours to 1200 hours. So basically noon on the 11th to noon on the 12th. We know it's good for 24 hours, this particular one. Tempo means that what follows next is going to be the following conditions are going to be kind of temporary, kind of transient. And then you'll see the period of time that the following conditions are valid for. So now we're kind of moving, we already established when it's going to start. Now we're saying, hey, we're temporarily going to see these things on the 11th day of the month from 12 to 1400 hours. So from noon to 2 p.m. Visibility is 5 SM. Whenever you see SM, a statute miles, that's indicating visibility. Remember what BR meant from earlier? Mist, there'll be some mist. From, FM is from 3 o'clock. Now we're moving on to like a different time. From 1500 hours from 3 o'clock. This code has a KT in it. Remember, KT stands for knots, which means the whole thing indicates wind speed. First three digits indicate the heading, just like METAR, so 160 degrees southeast, at 15 knots, gusting to 25. So we see 160 degrees, 15 knots, gusting to 25 knots. And during this time period, SM, remember SM means statute miles. It's a measurement of distance. That's your visibility. So 6 statute miles, they just put a P if it's 6 or more. That means you have great visibility. And now this is a description of the clouds, the various cloud cover, because pilots care about clouds. SCT means scattered clouds at, what's the altitude here the clouds are at? Remember, we add 2 zeros. So 4000, 4,000 feet. Scattered clouds at 4,000 feet. Broken clouds at, add 2 zeros, at 2,500 feet. No, 25,000 feet. Broken clouds at 25,000 feet. It gets really confusing to add 2 zeros. It'd be way easier if you added 3 zeros, but that's not how they do it. Now, FM, that means from. So again, we're indicating a different period of time. The first 2 digits here, we have 6 digits here. So we know the first 2 digits indicate the day of the month. So this is the next day, 12 o'clock at midnight. 4 zeros means midnight. KT indicates that it's wind speed, right? 140 degrees at 12 knots. Our visibility, 6 statute miles. The P in there indicates that everything is good. Again, now we go into a description of cloud cover. You can see now it's just a pattern. Now we've already seen all the different things we're going to see in this TAF. It's now telling us that's what it was. You know, this is the weather from this time to this time. And then for the next block of time, this is what the weather's going to be like. So starting at midnight, we're going to see broken clouds at 8,000 feet, overcast clouds at 15,000 feet. And there's a 30% probability, prob 30 means a 30% probability on the 12th day of the month, 1200, 12th day of the month here. This is a time period with a slash in it from 0, which is midnight, to 4 a.m. of visibility dropping to 3 statute miles. 30% probability of that. TSRA, remember what that meant? Thunderstorms and rain. Broken clouds at 30, and then add 2 zeros at 3,000 feet. Cumulonimbus clouds. And then the next time period here from the 12th day of the month, from 4 a.m. all the way until midnight. So this is a longer forecast, a longer period of time. The weather's probably going to stay stable. We have wind at 140 degrees at 8 knots. Visibility 6 statute miles, so clear visibility. Scattered clouds at 4,000, overcast clouds at 8,000 feet. Temporarily from on the 12th day of the month, from the 4th hour to the 8th hour, from 4 a.m. to 8 a.m., low visibility at 3 statute miles, thunderstorms and rain showers, and then overcast at 3,000 feet, cumulonimbus clouds. Whew. Not that hard. Not when you first look at it, it looks like it could never make sense to you. But I promise when you figure out just a couple of key things, you realize it's just repeating patterns that makes sense. They actually label KT means knots, means wind speed. Times with a slash indicate a time period starting with the day of the month and then the hour. Let's talk a little bit about weather. They want you to understand the effects that changing weather conditions can have on the performance of your craft. You're going to see the term density altitude. Density altitude indicates, well, at higher altitudes, air is less dense. Most people know that. That's why when you get an airplane, the cabin has to be pressurized. So high altitudes have a low density of air. Low altitudes have a high density of air. They'll use the terms low density altitude to mean the density at low altitudes. And the term high density altitude means the density at high altitudes. So what do you think the performance of your prop is going to be at really high altitudes? Do you think it's going to have better performance at high altitudes where the air is thin, or worse performance? It's going to have worse performance, right? That's why you can't just fly your drone straight up into space, because at some point it would get high enough where the air would be so thin that it couldn't spin fast enough and it couldn't get enough lift. Air gets thinner, performance gets worse at high density altitudes. Here's a question about that. What effect does high density altitude have on the efficiency of a drone propeller? Drone efficiency is decreased, like I just told you. Easy, right? They want you to know the term fronts. You know how the weather guy will say like, oh, there's a cold front coming in, there's a warm front coming in. What that actually means is there's a bunch of cold air hitting a bunch of warm air, and that division is considered a front. For weather fronts divide weather patterns. Wind shears are sudden drastic changes in wind speed, and they can happen in different wind conditions. But what I want you to know is that wind shears can happen at any altitude. They don't just happen on the ground. They don't just happen at higher altitudes. They can happen anywhere, and they can be dangerous. Now, as long as the wind shear, in practice, as long as the wind shear doesn't exceed the maximum speed of your drone and the drone has GPS and stuff, it's probably just going to hold mostly steady, maybe waver a little bit. But if the wind shear does exceed the maximum speed of your drone, it could get pushed beyond where you expect it to be. It could just suddenly take a jump 500 feet east, something like that. Structural icing is ice forming on the wings or the plane or something and actually like becoming part of the structure. It's scary. It's not something that you want. It can happen in a couple of conditions. You need some sort of water, some sort of precipitation, like it's raining or you're flying through a cloud, which you shouldn't be doing either of those, but they still want you to know about it. And it needs to be cold, like below freezing, so 0 degrees Celsius, where water freezes, or colder. Let's talk about the life cycle of a thunderstorm. You probably won't ever want to fly in a thunderstorm. It's scary, but they want you to know some information about it. Those big cumulus clouds, big puffy clouds, those can become thunderclouds. Not all cumulus clouds become thunderclouds, but all thunderclouds start life as a cumulus clouds pretty much. The cumulus lifestyle, or the thundercloud lifestyle, starts with a cumulus cloud. It moves into the maturing stage and then ends in the dissipating stage. 3 stages of the thundercloud. The mature stage is the most dangerous and intense. You clearly don't want to fly in that. I just want you to know that the mature stage is the dangerous one. Cumulus cloud, not dangerous. It's obvious, right? Thunderclouds are dangerous. The dissipating stage is when it starts to disappear, and during the dissipating stage, you can see downdrafts start to occur. So I want you to know about that. Humidity drastically affects several different aspects of flying a drone. First, humidity makes air hazier. As photographers, we already know this. So it reduces your visibility, but it also makes the air a little bit heavier, which can actually make the efficiency of your drone a little bit better. Unstable air tends to be hot and humid. So hot and humid air will be the most unstable. It kind of makes sense, right? Like when you heat stuff up, it starts to move around a little bit more, so you could expect that. Turbulence is caused in air that is unstable and showery. I just want you to associate those terms. It seems obvious, right? Unstable air would lead to turbulence. Here's a question about that. What are characteristics of a moist, unstable air mass? Would you expect it to be smooth? No, you would expect turbulence, because I just told you unstable means turbulence. Turbulence and showery precipitation. It's confusing because moist air will reduce visibility and would create haze. You would never see smoke, you might see fog. And humid air can also be smooth air, but the key here is that they say unstable air. So that's why you know it's going to be turbulent air. Stable air, because it will often be heavy air, it'll have a lot of humidity in it, the visibility can be poor. And it can also result in a steady rain rather than like rain coming down in sheets and varying a lot. It can just be like a nice drizzle. Here's a question about that. What are the characteristics of stable air? Again, we might see, probably wouldn't be good visibility because the humid air is going to be nice and stable. So it's going to be poor visibility and steady precipitation. Nimbus clouds are those big heavy clouds. I kind of covered that already. Stratus are those high wispy clouds. I just want you to know those terms. Let's talk about your team. The FAA doesn't want you to operate necessarily as an individual pilot, even though you can. They want you to consider the fact that you might have other people on your team. One of the team members you'll see referred to as a visual observer. Visual observer is not operating the controls. They're just watching the drone and looking out for obstacles. It's actually a good idea to have a visual observer. If you're going to put on some goggles and do first-person flying, which can be great for photography, you would legally be required to have a visual observer there because you have to maintain visual line of sight. So somebody has to be watching the drone, making sure it's not crashing into airplanes and stuff while you have those goggles on. You are the remote pilot in command. The remote pilot in command, the PIC, remote PIC, is the answer to a lot of questions. They're going to ask you who's responsible for this and that. The remote pilot in command. Let's look at some sample questions. When using a small drone in a commercial operation, who's responsible for briefing the participants about the emergency procedures? The remote PIC. It's almost always going to be the remote PIC. The only other time it's not is when they say, who helps the remote PIC do this? It's not the remote PIC, doesn't help the remote PIC. In that case, it would probably be the visual observer. Whose responsibility is to inspect your drone to ensure it's safe? The remote PIC. Who's responsible for determining the performance of the drone? The remote PIC. They're asking these because they want you to acknowledge that you are taking responsibility for everything as the remote PIC. I just want you to know the term crew resource management because this is the FAA's strategy for like keeping your team together and making sure that everybody's like sober and not roughhousing and causing problems and stuff. That's your job, again, is crew resource management. So crew resource management must be integrated into all phases of the flight, the planning phase, the actual flying phase, the maintenance phase, inspections phase. All of that involves crew resource management. Might be a question. Let's talk about risk and what the FAA wants you to know about it. They've identified a bunch of different risk factors. One that they're really concerned about is hyperventilation, and that's not something that I can imagine. Like a pilot of a manned plane pilot might get nervous and scared and start to breathe too fast. That's what hyperventilation is. You actually breathe too much. You get too much oxygen, and it can make you lightheaded, make you dumb. Hyperventilating is breathing too much. So what do you think you should do if you're hyperventilating? Should you breathe faster? Should you get some exercise? No. You might see questions asking you about hyperventilation. Don't breathe more. Calm down. Recognize that hyperventilation is bad. Alcohol is bad when you're flying a drone. Other times it's generally great. But if you're going to be flying a drone in the future, alcohol is bad, and they want you to know that, despite the fact that every small airport I've been to always has like a bar like right there. Anyway, it seems like pilots love alcohol, and the FAA recognizes this, and they want you to know alcohol and flying drones should never intersect. What is true regarding the presence of alcohol within the human body? A small amount of alcohol increases vision acuity? Do you think that's the answer? No. The FAA is not going to ask you a question that indicates that alcohol gives you some sort of superpower. If they ask about alcohol, the answer is going to be whatever the worst case scenario is, right? And on this one, alcohol causes judgment and decision-making abilities to be adversely affected, even small amounts of alcohol. This is a super easy, obvious question. The FAA just wants you to go through the process saying, yes, I know alcohol makes stuff worse for me. If you're hungover, even if it's been 8 hours, if you're hungover, you're still under the influence of alcohol, and you shouldn't be operating any sort of aircraft, including an unmanned aircraft. Fatigue is also one of those things that's bad, like alcohol, and they want you to know that. You're a remote pilot for a co-op energy service provider. You're going to use your drone to inspect some power lines. But as you drive out there, you become fatigued. And is that good or bad? Fatigue is bad, right? So fatigue can be recognized easily by an experienced pilot. No, again, it's going to be, if it's something dangerous, the answer is going to be the worst case scenario, as fatigue can be recognized as being in an impaired state, not the ability to overcome your sleep deprivation. No, that would put you in greater risk. Let's talk about how to scan the sky for threats. You need to make sure planes don't come in and crash into your drone, right? So they want you to be looking out. They don't want you to be like continuously like scanning left and right. No, what they want you to do is look at this section of the sky, stare at it for a few seconds, make sure everything's clear, then look at this section of the sky, stare at it, then look at this section of the sky and stare at it. That's how you scan. You don't continually scan. You don't use your periphery. You look directly at a space in the sky. This is from the FAA chart. You can see 1, 2, 3, 4, not back and forth nonsense, but you just look at the different areas, stare at them, make sure that everything is clear. Look for movement, like look for planes and stuff. It's effective. It's a more effective way to scan. So what technique should a remote pilot use to scan for traffic? Systematically focus on different segments of the sky for short intervals. Now you know that. Let's talk about a bunch of personality traits that don't make for good pilots. These are personality traits that increase the risk of flying. One is macho. Macho people do things to prove that they're the best or to show off or something. So maybe I take my drone dangerously close to people's heads to show what an awesome pilot I am. That's machismo, and it could lead to people being hurt. Impulsivity is a lack of planning. It's somebody who does something without thinking about it too much. Like if I'm just like, it's snowing, I think I'll just take my drone out. And that's impulsive. What's the antidote to impulsivity? The FAA might ask you what the antidote to any of these conditions are. The antidote to impulsivity is proper planning, recognizing that planning is important. Some people feel like they're invulnerable. They say, it can't happen to me. So what's the antidote to invulnerability is it can happen to me. Just like acknowledging, yes, these risk factors are real. I'm not perfect. Bad things can happen to me. What's another personality trait they want you to know about is resignation. People who have resigned themselves say, it doesn't matter what I do. The accidents are in the hands of the gods. It's just fate. It's going to happen or it's not going to happen. So I don't need to sweat it. It's out of my hands. They want you to know that the antidote to resignation is, yes, you are in control. You can mitigate risks. It is your responsibility. Another personality trait is anti-authority. People who are anti-authoritarian do things specifically to defy rules. FAA tells them not to fly over 400 feet. They're like, screw you, I'm going to fly at 600 feet. Rules should be followed. That's the antidote to the anti-authority personality trait. This is on the test. I know it seems weird. That's on the test. Here's one sample test question. Identify the hazardous attitude or characteristic a remote pilot displays while taking risks in order to impress others. Macho. Macho people take risks to impress others. You've been hired as a remote pilot by a local TV news station to film breaking news with your drone. You expressed a safety concern and the station manager has instructed you to fly first, ask questions later. What type of hazardous attitude does this represent? And that's impulsivity, because he's doing away with planning. He's being impulsive. Crew resource management, I talked about this a little bit earlier. It needs to be integrated through all the different stages. This is how you manage your visual observer and you yourself as the remote pilot in command and anybody else who might be in your crew. Here's a question about it. Safety is an important element for a remote pilot to consider prior to operating an unmanned aircraft system. To prevent the final link in the accident chain, a remote pilot must consider which methodology. Now, it's probably crew resource management, though this question is not clear to me at all because risk management is also a thing and something that should be considered as well as a safety management system. So some of the questions you're just like, I don't like any of those seem okay. And writing questions is hard. Let me tell you that. I've written thousands of questions. I used to work on certification exams for Microsoft and for like CISSP certifications, and writing questions is hard, and people who write questions often do a bad job of it because you have to write 500 questions and you get bored and tired, and pretty soon you're throwing out stuff that doesn't even make sense. That's one of those questions that just doesn't make sense. So I'm sorry, you'll have to see that. When adapting crew resource management concepts to the operation of a small drone, CRM must be integrated into, and again, they don't want, it's all phases of the operation because they will always err on the side of being too safe. They're never going to say, you don't have to worry about crew resource management for this phase, right? Err on the side of being too safe. Another local TV station has hired you to fly their drone. They've had a bunch of near misses and a couple of accidents. What is a solution to this? So, of course, they're going to err on the side of the safest thing. You don't have to study this. It should be obvious to you if you have common sense. Is the answer the news station does not need to make changes? Sometimes accidents are just unavoidable? No, of course not. The answer is the news station should recognize hazardous attitudes and situations and develop standard operating procedures that emphasize safety. Anybody could get that question right without knowing anything about the test if you just had some common sense. That wraps up my cram. Now I'm going to give you a few tips for taking the test. I like to do things in two phases. I study, I bring as much information as I can into my long-term memory, but as I'm studying, I'll get a sense for what stuff I am not retaining properly, and I will write that down in a little personal study guide for myself, all the stuff I can't remember. And for that, I cram. And I will arrive at the testing facility usually about 30 minutes before I need to walk through the door. And in those 30 minutes, I will just be looking at those little facts and trying to get them in my head, at least into my short-term memory. Then, when I get into the testing center, I will write down those facts on a piece of paper. That way, if I forget them at minute 35 or whatever, I can refer back to my notes. But you know what? By the time you actually write them down and everything, they're probably going to be in your long-term memory. That's a funny thing about cramming stuff into your head, is it kind of makes you retain it. So another thing is the process of elimination. These questions only have 3 answers. So 1 right answer, 2 distractors, which means if you have no idea what a question is, you still have a 33% chance that you're going to get it right. But there's always 1 really dumb answer. So on those questions, you will have a 50-50 chance of getting it right if you have no idea. So even if you're just guessing, you can get most of the questions right. That should be encouraging to you. The computer system will give you the option to answer the question, but there's a mark button. If you're unsure about something, mark it. Answer it. Give your best answer, but mark it, and you can come back later. Sometimes you'll see a later question that gives you, like, the information in the question itself will give you a clue about an earlier question, and you'll be able to circle back and figure it out, or maybe you'll look at the legend and remember, like, oh. Anyway, I always review those marked questions afterwards. When I took my test, I got an 88 on it, and I had a lot of marked questions that I didn't feel 100% confident on, but I still managed to get 88%, which means even though I wasn't 100% sure about some of the rather vague questions, I still managed to get most of them right just by good guessing. And lastly, don't stress. If you fail, the FAA drags you out of there, beats you, and never lets you fly a drone again. No. If you fail, no big deal. 2 weeks later, you can take the test again. Yeah, you're out the $150 testing fee and whatever time you have to drive in, but it's not the end of the world. You just get to retake the test in 2 weeks. They don't publish you to a list of flunkies or publicly humiliate you or anything. It's not a big deal to fail the test. I passed it on the first time, and I bet you will too, because it's a pretty easy test. But anyway, don't sweat it too much. Just to remind you, go to scp.io/tutorials to find tutorials to help you actually fly your drone or to use your camera. Mostly they're camera tutorials, but we're adding new drone tutorials in there. Subscribe to the channel, please. That's what we get out of this. That's why this is free. We get subscribers. I hope you'll come back later, watch other videos, and maybe even buy some of our books, like my book, Stunning Digital Photography, which just teaches you how to take great pictures, whether using a smartphone, an SLR, or one of these flying camera things. They all have over 12 hours of videos in them, so if you hate books, you can just watch the videos. Or if you like books, you can read the book and watch the videos. That's the best way to learn. Ebook versions, which run on a tablet or your smartphone or your computer, only cost $10. Paperback books are cool. They include the free ebook, and they cost you about $20. I have books on photographic techniques, stunning digital photography, the #1 best-selling book in the world, photography book in the world. I'll revise that. Go to Amazon, you can look up reviews. It has like 1,800 reviews and an awesome rating. I have books on Lightroom and Photoshop, which you will need as you're doing drone photography to make your pictures look the best. So those books will help you actually figure out how to use that software. And a book on photographic gear, things like camera lenses and stuff like that. You can get them all at Amazon. Search for my name, Tony Northup, or visit scp.io/store, where we ship worldwide. Thank you so much. I'll see you in the next video. Don't forget to subscribe. If you have questions, ask a comment down below. If you have tips, something I missed, something you found on the test, or something that was wrong, add a comment down below. I will compile any updates and put them in the description for people. Thanks. Bye.